Okay. So, we are writing the function into that form, okay? It's a weird form, so all I want us to focus on is that we're going to do some division first, okay? And then we'll deal with writing it in this funky format, which is x minus k, which is this thing, times the quotient plus the remainder. We're not going to have to do it that way every time. It's just that's what the instructions are asking us for, so that's what we're going to give them, okay? So the first thing I'm going to do is I'm going to do synthetic division, believe it or not, even though I've got a radical there, because I'd rather do synthetic with this and just deal with the numbers than try to long divide this, all right? Synthetic is your friend. We'd rather do synthetic over long if we can, okay? The only time long division is good is if I have more than an x to the first power. If I have an x squared or a cubed, I have to use long division. All right, so the difference between yesterday and today is, notice instead of it saying k plus the square root of 5 equals 0 or k plus the square root of 5, notice it's k equals that. So in this case, I keep the sign that is there for the synthetic division. Yes, we're going to work with radicals. It's okay. All right. What are we going to get for our coefficients? 1, then what?
2.
Notice I'm leaving extra space, then what? And then,
4.
good. Our first step in synthetic is to do what with the 1? Drop it down. Good. Negative square root of 5 times 1 is what? Good. I cannot combine those together, right? So when I add them, I would write it as 2 negative square root of 5. That's why I wrote extra space in there. Okay. Then I'm going to multiply negative square root of 5 times this. So I have to distribute it through. So what's negative square root of 5 times 2? Negative 2 square root of 5. Notice where I wrote it. Okay. Negative, so I now have negative square root of 5 times negative square root of 5 is what? Is it going to be positive or negative? Positive. A square root times itself is just what? 5. There you go. Notice I put that in front, because we tend to like to put the radical in the back. Just like we put the I in the back, we put the radical in the back. All right, so I'm going to add these together. I'm going to add like terms. I can add the 5s together. I cannot add it with this radical 5. It acts like an x. So it's negative 5 and positive 5? 0. So I just end up with negative 2 square root of 5. All right, let's multiply that. So negative square root of 5 times negative 2 square root of 5 is what? I have a 2. I'd have 2. The negative times the negative is going to go what? Positive. Square root of 5 times square root of 5 is what? 5. So I'm doing some scratch work here. I end up with 2 times 5. What's 2 times 5? 10. So what does the remainder become? 6. All right. Now we have to write it in this weird funky format, right? So f of x equals, all I'm doing is following this. What's the k value right now? What does it tell us? Negative square root of 5. So that's going to go positive. It wants the quotient, which means write the original function. Okay? So the original function, no, I'm sorry. It wants the quotient. Write the answer. So we're going to write instead of this being x cubed, what are we going to start with? So it'd be x squared plus this weird coefficient, 2 square root of 5x, minus 2 square root of 5. And then it says write plus the remainder. So we don't write the remainder over its whatever we divided by. We just write plus 6 on the end. That one, like I said, the formatting is weird. Are we necessarily going to do that too on the test? Probably not. Okay, but it's always good to look at different instructions. Okay, let's talk about the remainder theorem. So I want you to go ahead and fill in those blanks for me. Okay, so the remainder theorem says that if a polynomial f of x is divided by x minus k, the remainder is if we put the k value into the function. Okay? Basically, to find the remainder, okay, it gives us the value x equals k. In other words, we can plop it in there and evaluate it. Okay? If r equals 0, then we know the remainder is 0, then we know x minus k is a factor, and k0 is an x-intercept. So basically what our goal is to get the remainder to be 0. Okay? So, if we don't get the remainder to be 0, then this thing here is not a factor of it. So we're supposed to use the remainder theorem to determine if x plus 1 is a factor of this. I'm not going to use long division. I'm going to use synthetic because it's quicker. Okay? So when I have the parentheses, I have to do what to the sign here? Change it. So I'm going to go -1. All right, what are we going to use as our coefficients for synthetic?
4, 10,
-3, -8. Good, there weren't any holes or anything goofy. There's no weird radicals this time. What do we do with the first 4? Drop it. Good. So -1 times 4 is? Good. 10 minus 4 is? 6. -1 times 6 is? Good. -3 and -6 are? Good. -1 times -9 is? 9. -8 and 9 is? Did I get 0? No. So is it a factor? No. So we would say, and I would write not a factor. That's sufficient for homework. For your notes, I would write why. Because 0 is not the remainder. So I would write that into my notes. So when I'm looking, remainder. Because that way when I'm looking back on this and when I'm trying to do my homework, you should go be flipping back to your notes when you get lost. Then you know what we did there, why it didn't work. Okay? All right. So, let's take a look at this next one. Instructions are different again. It says, use the remainder theorem in synthetic division to evaluate the function at each given value. Okay? So, I want you to believe that this works. Really quickly, in your calculator, okay? So, use your calculator. I want you to plug this in. I want you to plug 2 into that function and get an answer. So, everybody's going to put 2 into this function and get an answer. You're going to tell me what that answer is here in a second. Probably not.
47.
What?
47.
That's not what I got either. I like 59. Well, we should put f of 2 equals 59. Okay. Double check, make sure you're getting the 59. Okay, so back in that remainder theorem, it said that the remainder is what we get when we is the same thing we get when we plug in a number into the function. So let's try that. We're going to look for the remainder right now. So I'm going to use this number exactly in my synthetic. So I'm going to put a 2 there. I'm going to use synthetic division. I'm going to grab my coefficients. So what are my coefficients?
3,
8. What else?
5, -7.
Good. All right, what are we going to do with this 3? Drop it. Good. 2 times 3 is?
6.
Good. 8 plus 6 is? 2 times 14 is?
28.
Good. 28 plus 5 is?
33.
Good. 2 times 33 is?
66.
-7 and 66 is?
59.
Do you see how this and this are the same?
Oh my god.
Isn't that pretty cool? Okay. So, instead of using your calculator to evaluate, this was pretty easy to arithmetic to do in our head, right? Whereas calculator, I would have been writing some work down. Okay. So I would have been writing quite a bit of work down if I was trying to evaluate that by hand. All right. So this is another way to do it. You don't have to do it that way every time, but it is a valid method. So let's try it again. Okay. In fact, I'm going to have you try B on your own. What's going to go in this box to begin with?
-3.
-3. And you're going to use the same coefficients we did on the last one. Okay. So everybody's trying your synthetic division right now. All right, let's check this. So -3 times 3 is what? Good. 8 and -9.
-1.
Good. -3 times -1. 8. 5 plus 3? 8 times -3. Remainder is -31. Okay? So f of -3 is -31. All right, let's keep going. So write that down for your factor theorem. Alright, so a polynomial has a factor x minus k if and only if basically the remainder ends up being 0. Okay, so we've kind of already talked about that. So we're basically looking for the remainder of 0 again. So we're going to use synthetic division to show that x is a solution to the third degree polynomial, okay, equation, and use the result to factor the polynomial completely. There is something missing, isn't there? The x. Okay, so I've written down an x for us. So the x you need to add in there should be x equals -3. Okay. All right, so let's use synthetic division, and then we'll talk about how we set this up and show it factored completely. Okay. So what's going to go in the box? Negative. It's already solved for us, so we go -3. What are our coefficients? Be very careful.
0.
Good.
-19. -30.
Why did we have to put the 0 in?
Because we're missing x squared.
We're missing x squared. Okay, so we had to put the 0 in. All right, drop the 1. That's -3 times 1. 0 and -3. Good. -3 times -3. -19 and 9. -10 times -3.
30.
Did we get the remainder we wanted?
Yep.
Yes. Okay, so that means what's left behind would be x what? If it's cubed here, what's my next one? Squared minus 3x minus 10. It wants me to factor completely. Do I have to do synthetic division to factor that? No, what can I use? Magic x. So synthetic division is a way to get it broken down till we can get to a quadratic, and then we can do whatever, all the other factoring that we've done before. Okay? So two numbers that multiply to -10 and add to -3.
-5, 2.
Good. So we would write that as x plus 2 times x minus 5. Now that's just this. We need to show the result for that right there. So the other factor, if I got this back equal to 0, how do I move this back to the other side? Add it. So really this is the saying x plus 3 equals 0. So my other factor is x plus 3. Basically, what did we do to this sign? switch it, right?
After you get x plus 3.
So they gave me the x minus 3, right? That's what it was a typo. It should have been in there. Once you get it when you get it back equal to 0, you know it's a factor. So I added the 3 to the other side, so that was the factor. Could I check this and make sure I was right?
Yeah.
I'd FOIL and multiply it out, and I should get back to the original. Okay, I'm not going to do that, but I could do that. Okay?
Good.
All right, write that down.
That's a small one.
Time to learn. You're fine. We have plenty of time. I know. I should be almost out of here. Is that if I can go with that clock? It means I get to go home in an hour. Okay. You ready? Not yet? You don't need all the little hashtags underneath. Just write factors of a constant term divided by factors of a leading coefficient. When I put it into the equation editor, you have to put that in there to get a space. So. All right, so let's see if we can read what the test is here. So if the polynomial, remember that's a generic name for a polynomial, has integer coefficients, all right, so plus minus kind of numbers. Every rational zero has the form p divided by q. So we're not talking about i's yet, because i's are complex. We're just talking about rational things. Where p is a factor of the last term, so p is a factor of this, q is a factor of the first coefficient. The possible rational zeros are factors of a constant term divided by factors of leading coefficient. So what happens if they don't give us one? We have to be able to guess. I'm not going to guess from every number in the world. This gives us a list of things to guess from. Okay? So we're going to try to write just the list out this time. And then we're going to do example 11 and cross out 12, and those are going to be our last, it's going to be our last one today. Okay? And we'll pick up from example 13 tomorrow. Okay? And I'll adjust the homework here. So, use the rational zero test to list all the possible rational zeros of f. So first of all, I want to find all the factors of p, which is the last term. So, what times what is 8?
4 and 2.
4 and 2. Anything else?
-2, -4.
Okay, I like -2, -4, so we're going to make them plus minus.
1 and 8.
1 and 8. Don't forget the 1 and the 8. And then we could make them all plus or minus, right? Okay. Now I want to look at the factors of q, which is the first term. So q is the first coefficient. What's my first coefficient?
1.
1. So what are its factors?
1.
Plus or minus 1, right?
Yes.
Okay. So now I have to figure out what are all the possible rational zeros. So I take p and I divide it by q. So p is 1, divided by 1 is still 1, right? 2 divided by 1 is still what? 2. So basically I'm taking this and I'm dividing it by that. Taking this one, dividing it by that. 4 divided by 1 is 4. 8 divided by 1 is 8. I'm being very explicit in what I'm showing you, right? Because is it always going to be a nice pretty 1 here? No, you're going to have some fractions, right? So, and then we throw the plus minus in front of all of them. So those are our possible zeros. So instead of guessing from all the numbers what would divide that, I'd guess from those 8 numbers that are there. Okay? So we're going to see that put into action here in example 11. You will need the space for 12. Okay? So cross out 12. How did I get the factors of p? What times what is 8? Right? Think about, or think about doing a factor too, but I ask myself what times what is 8. Okay? All right, let's look at 11. So it's supposed to use the rational zero test to list all the possibles and then find the rational zeros. I'm not looking for imaginaries, I'm just looking for the rationals. Okay? So I'm going to do p divided by q again. So I'm going to do my factors of p, and I'm going to write, notice I'm writing smaller, and my factors of q. So again, this was the last term, and this is the first term. Okay, so my last term is 3. What times what is 3? 1 and 3, and we would know they're plus minus. All right, what's my first term? 2. What times what is 2? 2, 1 and 2.
Plus or minus.
Okay, plus or minus. And then we're going to do our possible p divided by q. So this is the list we're going to use to guess. All right. So let's do our p. So what's on my first p? 1. And divided by, let's say divided by 1 gets us what? 1. I'm not going to do the 1 divided by 1. I'm not going to show that. We're doing it in our head. Now I'm going to go back here. 1 divided by what? 2. So see how I exhaust the list? I do that number over both of those. Then I move on to the next number. So now I'm doing 3 divided by 1, which is 3. 3 divided by 2, 3 halves. And then make them all plus or minus. All right, I'm going to see if I can guess. So I'm going to pick one of these 8 numbers and use synthetic division to divide it here. I'm going to start by choosing -1. I'm doing this on purpose so you see what to do if you guess wrong. Okay, so this one's not going to work. Yes, Alexis.
Why do you have to make them all plus or minus?
Because because if I multiplied 3 times, sorry, if I multiplied -1 times -3, wouldn't I get 3? So -1 and -3 are factors of it. Okay? Because we're talking about integers, not just the whole numbers. Okay? All right. So I'm going to go ahead and list my coefficients. What are my coefficients for synthetic division? 2. Good. What's my next one? 3 then? -8 and 3. All right, and I'm purposely picking one that isn't going to work here, so you see what you do. So I drop my 2. -1 times 2 is? Good. 3 and -2 is? -1 times 1 is? -8 and -1 is? -1 times -9 is? 9. And then 3 plus 9 is? What number did we want here if it is a factor? 0. Did I get a 0? No. So did I guess right? No, but I've eliminated that possibility. All right, let's see if I can guess better this time. I'm going to pick 1. Okay. So we're going to use the same coefficients because I haven't factored anything out yet because I haven't found a 0 yet. Do you see why you're going to use the space for 12? Okay, so just cross 12 out. We'll get rid of it. All right, 2 times 1. 2. 2 plus 3. 5 times 1. Plus -8. -3 times 1. Did I guess better this time? Yeah. Okay, so now we're going to do what we did a couple examples ago. I'm going to do some factoring from here. Okay, so I started with a cube. What should this be? 2x squared plus 5x minus. And if I have to find the zeros, I'm going to set that equal to 0. Okay? I know let's make a list of zeros. I know one of my zeros is 1. Okay? The rest of my zeros, I'm not going to have time. It's already 55. Sorry. So when I factor this thing, okay, it's 6, -1, and then we have to do a box. I'm not going to do the whole factoring because we're running out of time. We do this times that. It ends up being that, so I end up with, when I do the work, x equal to 1/2 and x equal to -3. Are those two things on the list?
Yeah.
Yeah. So 1/2 and -3 would be my other zeros if I'd gone through with the factoring. Okay, what I'm going to do is I'm going to adjust the assignment. So I will adjust it in Haiku right now, okay, to match what we actually did. And then you guys will look it up in Haiku.